Okay, let me do a sound check. Brian, can you check the audio? It'll probably take a few seconds. Yep. Hello. Morning. All good? All right. Okay, so guys, let's get these proceedings underway. First, just a few housekeeping announcements. Somebody has their YouTube audio on. You might mute it if you do. I'm hearing a slight echo. Okay, all right, maybe. Oh, maybe it's me. Ah, yes. All right, cool. Okay, like, we have a nice 3-hour presentation set up for you this morning. The agenda is in front of you. One thing to remember is that we are going to live stream this event and also record it. So all the questions and everything is going to be recorded. I hope that's okay with you. We do it mainly so that we can save these proceedings for archival purposes, share it with our sponsors, and so on. The other thing is that we do want audience questions also to be heard by everybody, including the online audience. So we do have lots of time for questions during these presentations. So if you have questions, please raise your hand, and we will circulate one of these mics around to you and speak into that. It's not going to amplify for the room. It's only for the online audience and for the recording, right? And so that also gives us time to pace the questions and make sure everybody's questions get in. And if you're listening to this live online, you only have the option to type your questions into the chat. And I unfortunately have some bad news for you. We've tested this several times. YouTube has a 25-odd second lag, which means that after I say something, you hear it 25 seconds later. And then if you immediately ask a question and we immediately respond to it in the chat, you hear my answer 25 seconds after that. So more than a minute might pass. So be patient. For the online audience, the best thing might be to just wait for the question answer period at the end of the talks and ask your questions at that time, because otherwise it's going to be rather, like, you can imagine a 1-minute round trip delay. So it's a bit, but again, the option's there. So please don't hesitate. The chat is low. That's why I said 2 times 25. Oh, but usually the questions would be to the speakers and yeah. Okay, all right. Okay, cool. No, Jason Eisner, my colleague, is pointing out that maybe we should answer them in the chat as well. But no, I don't. I want the speakers to, at least I can only do one task at a time. All right. So with that, and let's see, any other housekeeping announcements? The restrooms are directly behind you, behind that wall. We will take a break in the middle to walk around, stretch our legs. So you can refill your coffee at that time in case your blood caffeine level is too low. And we'll go from there. All right. So any housekeeping-like questions before we jump into the program? All right. OK. So let's jump into the program, if I can. There we go. So this is the 10th Frederick Jelinek Memorial Summer Workshop. It's the 31st workshop by a different count, but I'll tell you about that in a minute. And I'm Sanjeev Khudanpur. I'm a faculty member here at Hopkins. And Paula Garcia and Antoine Laura are my co-organizers. And we have the 4 team leaders from whom you'll hear today. So this is a joint presentation by all of us. So first, how did we get here? So the title of my talk is something like The Road to JSALT 2024. And the road really begins way back. It begins back actually in the 50s. In the 50s, there was a tradition at the Center for Communications Research, which is part of the Institute for Defense Analyses in Princeton, of having something called SCAMPs. There were summer camps in applied mathematics and probability or something like that. And they had a very simple plan. They'd get a bunch of academics, typically of the order of 30, 40 professors, put them in a nice building, give them lots of chalk and blackboards, and they would solve cryptology problems. And of course, they had computers too, but yeah. Anyway, so it was a very successful series of workshops. It's been running continuously since then, even today. And IDEA has grown and there are other campuses. But this workshop has a long history of solving really hard problems in cryptology, right? And for those of us in speech and language, in case you didn't know, the HMM forward-backward algorithm was invented at IDEA. Right, so they have a long connection to our field and this. So what happened is an experiment was started based on this idea about 30-some years ago. So in 1993, a summer workshop was held at the Center for Advanced Information Processing, CAPE, at Rutgers University. It was inspired by the work at IDA, the workshops at IDA. And while many people are given credit for it, including Arthur House, Tom Crystal, I think Kurt Boyles maybe, the people I associate most with it are Jordan Cohen, the person on your left, who was at IDA at the time, and Jim Flanagan, who had just retired from Bell Labs after a long, illustrious career and joined Rutgers. And they together put together the first workshop and invited about 30 or so researchers, usually from academia, but a mix of academia and industry. And that was the first workshop. And then they did a repeat in 1994. So these were the beginnings of the summer workshops as we know them today, right? They were different from the scamps in a couple of key ways. The scamps usually were all professors and focused usually on what I would call sensitive problems that the government works on. And they were mostly, in fact, 100% US citizens. The field of speech and language is much more open. The best people are all over the world. And so these workshops at Rutgers were more open. They were completely open and things were done in the open. So how did Hopkins get involved in the picture? Well, what happened is around 1994, Fred Jelinek, my mentor and the inaugural director of CLSP, came to Hopkins. And he was a big name in the field. And so the workshops followed him in the sense he said, okay, I will organize this and take care of it. And so that's when the first workshop happened at Hopkins in 1995 after Fred's arrival in 94. And one of the key things that Fred did is he made grad students a big part of the workshop. In fact, I believe there were a couple of grad students, a few at Rutgers as well, but Rutgers was more on the scamp model with senior researchers. Fred said, no, the students are the guys with the real ideas or the girls with the real ideas. So let's bring them in. So they made an integral part of the workshops. And this is when this grad student from University of Maryland joined the workshop and got involved in speech and language, although he was doing information theory at the time. So this is my first summer workshop as a grad student. So guess what we were working on in 1995? Anyone wants to guess? Language models. Yes. So the language models didn't come around in the last 3 years. They weren't invented by OpenAI. They've been worked on for decades and decades, right? So look at the topics: language models for conversational speech, language modeling in Spanish, fast and portable, meaning adaptive language models, phrase structured models. Yep.
Aside from the phrase.
Wait. Remember the rules. Yes, go ahead.
The models that weren't phrase structured were n-gram for what n?
3.
3-gram models.
Yes, those were big models at that time. We used to call them large language models. Murat.
I believe the workshop itself was called LM95, right?
Yes, the workshop was called LM95. And guess who else was in the workshop? No, you were in 96. Okay, all right. No, so we have many workshop alumni around here. Right, so that's how they started. And then, of course, we continued working on various things. So here's an interesting person who led a team at the summer workshop. He was this young postdoc, energetic guy from Berkeley named Dan Jurafsky. And you'll see him again in a few weeks because he'll be visiting again to give a plenary talk. Since then, he went to Boulder as a professor first, then to Stanford, wrote a book or two, dabbled in the connection between language and cooking and what else. But you know Dan. All right. And won a MacArthur Award. Yes, exactly. Okay, 1998. We added another dimension. Fred said, let's get some undergraduates. And this was purely a political move. He's like, we need to get the NSF people to support the workshop. NSF likes undergrads. Let's get undergrads. No, it was not that cynical. So 1998 was the first time we had undergrads in the workshop. And this is when the workshop sort of culture started becoming more set and more clear. Undergrads, grad students, senior people. And this is the team from 98 led by Jan Heitch, who's on your right, my left. Next to him is Eric Brill, who later on went on to be the CTO of eBay. And then he retired, and he's apparently fun employed these days. And then there are others you might recognize, like, in the middle is Michael Collins, who then was a grad student, later MIT, and then Columbia and Google. The two people on the left are basically, second from left is Cynthia Kuo, third from left is Oren Schwartz. So these guys are the first undergrads, and there were four others. So we started experimenting with undergrads. The workshops, did a lot of fun things. They've always worked on really avant-garde topics. So I just told you about Haich's team in '98, which worked on core NLP for multiple languages. 1999, there was a team on statistical machine translation. So what happened is in '94, there was this influential paper written by a bunch of people at IBM, Bob Mercer, Peter Brown, the Della Pietras, maybe Lafferty was on it, I can't remember. Yeah. Anyway, so this paper basically said, hey, to do machine translation, we can just use statistics. We don't really need rules and dictionaries and tables and this and that. But all these people who did this work immediately left IBM, joined a hedge fund named Renaissance Technologies, and never looked back. So this work was kind of lost to the world. So in '99, we put together a team to actually revive that work. And it was led by Kevin Knight. And this was the rebirth of statistical machine translations in the field of language technology. Similarly, in 2000, there was a team that worked on audiovisual speech recognition. So although these workshops started with speech as their focus and then speech and text as their main foci, they were always looking around at other fields, trying to make connections, see how things work. And so there was a team led by Chelapati Neti from IBM on audiovisual speech recognition. So computer vision was there in the workshops thinking right from the beginning. Of course, lots of major breakthroughs have happened over the years in these workshops. I'll name a few. And in fact, after I made the slides this morning, I was reviewing them and I realized I forgot another one. But anyway, in 2001, for example, actually, I'm already skipping one where we did some superb work on speaker ID. The team was called Super SID. And the team basically reduced the error rates on speaker recognition from the beginning of the summer to the end by about 33%, which was a huge thing. And by the way, that beginning of summer number was a worldwide competition, which had just ended in April or March. So they outdid that. It was terrific. And it was the talk of town for several years after that. It was called the Super SID team, SID, speaker ID. But they had a logo like Superman. And then, of course, in 2001, Drago Radev, who's unfortunately no longer with us, he led a team on multi-document summarization, created a toolkit called MEAD, which was used for a long, long time, might still be used today, I'm not sure, for multi-document summarization. Well, this open source business is another thing that the workshop does. Because we work in this open setting with different people collaborating, the products of the workshop, the outcomes are all shared by everybody. Right? So in 2006, there was this German guy who was at ISI at that time, had just finished his PhD at Edinburgh. And he said, oh, I want to do some machine translation, created a toolkit called Moses. And again, Moses became the de facto tool for machine translation in academia and industry for many, many, many years. Right? And he's right here with us today. But this is Philip from 2006. Looks the same for some reason, still has all his hair. All right. 2008, there was this team led by Lukáš Burget from Brno. And in his team was this really noisy grad student called Najim Dehak. And he came up with something called iVectors. And those things totally changed the field of speaker recognition, made a big quantum leap forward. And those became the de facto standard for doing speaker ID for many years after that, until they were displaced by another Hopkins invention, X-Vectors, but that comes later. Then in 2009, this crazy guy, Dan Povey, severely autistic in my assessment. I have no degree in psychology, but really fun guy. He led this team, completely haphazard team, which came up with this brilliant toolkit called Kaldi. And Kaldi became the de facto standard for speech recognition for many, many years after that. The work started at Hopkins in 2009. It was continued at Brno for a while, released in 2011, I think, or 2010 or 2011. And then lots of companies were founded based on it. And it is the backbone of the speech recognition was for the Amazon Echo when it was launched. We found out later on that Siri abandoned its old technology and switched to Kaldi at some point around then. So yes, you're seeing the impact of the workshop in your everyday lives, right? And the one I forgot to add to this is 2018, Takaaki Hori from Merle and Shinji led a team that created ESPNet. So if any of you do ESPNet for your speech recognition or other tasks, that's another workshop product. So you can see, like, Intel used to have the sticker Intel inside. So I think we should start putting Hopkins inside for all these devices that we use. Okay. Like I was telling you, the nurturing collaboration with computer vision is also an old thing. Like I said, Neti led a workshop team on audio-visual speech recognition in 2000. 2004, there was a team that worked on joint visual text modeling. Giri Iyengar from IBM at that time, and now he's at Capital One. He's the VP of AI, something or the other. And Manmatha, who later joined IBM, he was at Amherst at the time. So these guys were trying to model text and images together so that you could do video retrieval. So you could type in a text query and retrieve segments of video, right? And this is way before YouTube was a thing, I think, because I don't remember YouTube ever being mentioned in this workshop. Then there was a team in 2010. They said, okay, let's look for actions in video. And this was led by Jan Newman and Evelyn Zuckerman. Jan is still at Comcast, I believe, and Evelyn is at MITRE. And these guys said, hey, if there is narration and something going on in the video, oftentimes the words in the video will tell you what actions are happening in the video. And for this, they found a cool data set. There's a data set of cooking shows from PBS called PBS Sprouts. And the video shows somebody chopping onion and says, dice the onion really small. And you're like, hey, okay, there's action recognition. So there is some nice work connecting video with text. In 2011, there was another team. Tamara Berg and Alex Berg are household names in computer vision. They've done some really nice work. So they came here and led a team, again, on connecting text and images. And this really is clip before there was clip. Okay, they really had these things together where you could have model text and images, and their models, given an image, would come out with a caption like, this image has one boy standing behind one chair with one table and two boxes, and things like that. So it would actually spew out text captions for images. Really nice work. And then Andrea Vedaldi, who is now the co-leader of the VGG group in Oxford, he led a team in 2012 about detailed modeling of natural images. So they would have birds, and they'd describe the beak and the feathers and the tail and things like that. So computer vision has been part of our workshop thinking for a long time. So Samir, you're following in a good tradition when you start doing audiovisual modeling, right? Cool. 2014 is when the workshops went on the road. So all these years from 95 until 2014, they've always been at Hopkins. So in fact, many people even today call it the Hopkins workshop, even though sometimes it's not at Hopkins. That's okay, I'm fine with that. So in 2014, we went to Prague. This is where we also gave the workshop its name after Jelinek, because Jelinek had a long connection with Prague, both for familial reasons, and he was also a professor at Charles University. And so he passed away in 2010. So 2014, we had a workshop in his honor over there. And I like the idea of going out to other cities. So 2015, we went to Seattle, to University of Washington. 2016, 2017, we were in Pittsburgh at CMU. And Florian Metza, who visited us earlier, was co-hosting at that time. 2019, we went to Montreal to ETH. And 2023, we were at Le Mans, where Antoine's colleague, Anthony Larcher, and others, they hosted us. So roughly speaking, every other year, we go on the road, and then we come back here. There was an interesting thing. Once somebody who has been key to sponsoring the workshops met with me, and I said, well, this going to other cities is a good idea, but don't do it too often. I said, why is that? He said, well, you don't realize these workshops run on institutional memory. You need a bunch of people who know all the things that need to be done to get it right. And if you keep going to different places, it's not easy. So that's partly why conferences are always a chaos, because there's a different group organizing it every time. So this is not one of them. This comes back here and maintains its roots. All right. Workshops start a lot of things. One of them I really like is very long-term collaborations. So not every workshop is a super duper success like a Kaldi or a Mead or whatever, or Moses. But the connections that you make live on forever. So people talk, people have interesting discussions. So Franz Ock in the picture on the right, he was here in the summer between finishing his PhD in Aachen and going to Google. And all the ideas for Google Translate were consolidated. So he left here, went to Google, started Google Translate, and the rest, as they say, is history. So if you use Google Translate, again, you have JHU behind it somewhere. By the way, Franz was also part of that 1999 team which revived statistical machine translation, but then he was a grad student. This time in 2003, he was leading a team. So a lot of connections to what you do every day, use every day, good stuff. Undergraduates, yeah, in the beginning, we weren't sure what to do, about them. In fact, the 2-week summer school was partly motivated by having undergrads saying, hey, we need these people to understand what's happening in the whole workshop with all the teams and not just focus on their little problem. So we started doing tutorials, and they were a success. So Cynthia was the first undergraduate cohort in JSALT, 1998. Today, she's she did her PhD, went out to Silicon Valley, did a bunch of startups and this and that. And today she's a professor of the practice, helping entrepreneurs in CMU West, as I call it. It's called the CMU Silicon Valley campus. Another well-known workshop alumnus as an undergrad is Noah Smith. He's at UW, he's a professor. Apparently he's very active on Twitter, or formerly Twitter. But he was born here as well, meaning in the workshops, and then did his PhD. Here's another one. Not everybody becomes an academic. So David Kirsch did his bachelor's, went off and joined startups, went to industry, did really innovative things. But NLP never left him. So today he is the CTO of a company that does health informatics. And
how I know Facebook friends.
there you go. So Jason just said he and David are Facebook friends. Yes, exactly. And of course, one of the more recent ones, Rachel, she is now a professor at University of Maryland. So yeah, all in all, undergrads were a big success. So we're having more and more of them, as I'll tell you in a minute. But just in case you think the workshop happens in the summer, no, it actually happens all year round. Okay, it's a long process to get this whole thing done. So we start in September, let me use my mouse to point. So we send out a call for proposals. We typically have a deadline in October. We typically meet in November to figure out what we're going to do the following summer. And then a whole series of things starts. We fix the, remember, getting somebody to commit to be away from home and family for 6 to 8 weeks is not trivial. So we try to finalize the senior members first. They typically recommend grad students to us, so we pick those. Then we do a search for all the undergrads. We pretty much get 150 odd applications, pick 5 or 6. Then we ask the teams to meet in person. So I won't steal the thunder by telling you when they met. The team leaders will tell you their preparations. So typically we ask them to meet at least once, if possible twice, face-to-face. And so they meet in the spring, we prepare data. Then in June, we do the summer school. And then the real action happens in July and a bit of August. This is the part you're seeing now. And then you go home and start writing reports. And at Hopkins, you're back to the proposal. Okay. So this was the proposal for the workshop you're in. So it was sent out in early September last year. We had an October deadline. And we asked for a really broad range of topics, not limited to speech processing, text processing, multimodal AI, responsible AI. And there was a lot of discussion. Somebody looked at this very carefully. By the way, I don't expect you to read the text. Don't bother. It's on the website. Every paragraph has LLM in it. And I said, yeah, everybody's excited about it. Let's see what the hullabaloo is about and figure out what to do with it. So the response was quite nice. We got 6 ideas. One of them couldn't come to the meeting, so he withdrew. But we had about 14 authors, people who had proposed ideas, come to Baltimore for 2 days, November 10, 11, 12. So I say 2 days, although it's 3 days, because we start Friday evening and Sunday afternoon. And we invited another 20 people to join them to actually brainstorm and discuss. So altogether, there were 34 people in that meeting. 29 were in person, 5 people joined online. And of these, the bulk were from academia, 24, including 10 faculty from CLSP, Visit Hopkins, about 10 people from industry. So industry continues to be interested in these workshops. They watch you, they see what you're doing because they're curious. And then normally we get government people. This year we didn't. What we did over those 2 days is we presented the ideas, we critiqued them, we revised them, did it all over again. And these things, ideas slowly morph or cook or crystallize. You can pick your favorite metaphor into project ideas. And then we vote on them, right? So we do ranked choice voting, and people try to figure out which proposals are most likely to have a big impact on the field, which proposals are most relevant today, which proposals have a good team behind them. And we picked 4 projects, which basically became our workshop topics. So by the way, the leaders for these workshops also kind of evolve organically from these meetings. Remember, I said there were 14 authors, but who are the 4 leaders? Well, that happens as you go and you figure out who's got the most energy behind it and who's able to organize people around them and so on. So Marek Cruz from Pilsen is going to lead a team on sign language translation. The team title is simply Sign LLM. John from the Space Telescope Institute happens to be down the street from us, is going to lead a team on using LLMs in research astronomy, right? Jason Eisner is going to lead a team on AI-curated democratic discourse. It's a topic that both excites and worries us today, and we'll think about how to navigate through that. And Samir and Antoine jointly will lead the multimodal, multitask, audiovisual transformer team. So these are the teams. Roughly speaking, they all have a fair number of senior people. These are people with PhDs. So Fred used to call them grown-ups. I somehow don't like that term, but yeah. So they have a few grown-ups and a few PhD students and a few undergrads. And some of them have people from industry and so on. Right? Okay. So roughly speaking, the demographics break out this way. We have about 55 full-time people. By full-time, I mean if you're a student, you're here for 8 weeks. If you're a faculty member, you're here for at least 6 weeks, sometimes more. We have a few people, a couple on Samir's team, one on John's team, who are going to be part-time, meaning they'll come and go, but they'll be here often enough to count. And then altogether, we're doing okay with recruiting women to our field, but it's still a bit of a lift. We're at 25%. We need to get a little better. We'll get there. We're doing much better on the invited speakers, and I won't steal Paula's thunder. She'll tell you about it in a little bit. And overall, as Fred had envisioned, the workshops now have more students than senior people. So it's about 60% students, 40% senior people. So it's a good mix. And industry continues to be involved. And think about it, from industry, sending someone away for 1.5 months is significant expense. So the fact that we're able to get 4 people here out of companies is quite commendable. So let me stop here and go to the second part of the next part on our agenda, namely getting the team leaders to present their respective teams. So while Marek is coming over, does anybody have a quick question for me? Nope. Okay, I was expecting not, because this is basic stuff. All right, Marek, let me give you the microphone, and while you put it on, I'll tee up your slide. There we go.
Yeah.
All right.
Okay. Hi, everyone. So thanks for the introduction, and listening to the talk was very interesting. So it's first time for me being here. So it's good to see that we are following such a experienced people, such as successful people, and it definitely does not put me under any kind of pressure. And so I want to present to you our work, or our idea, what we want to do and what we've done on the topic of sign language translation. So when I came here in November, I wanted to present something smaller. I played around at the time with my student with poses, and we were trying to find out like what are the limitations of poses that there are for recognition of sign language. We did some isolated sign language recognition with it, and it worked pretty well. We have a nice paper. It just skyrocketed for me. It's now the most cited paper I have. And we invited Murad also, as he's also expert in sign language recognition, and he brought some ideas from, let's say, speech recognition or audio recognition. And lastly, Florian Metze showed up, and just while we were having discussions about how to fuse these ideas of poses and the approach from speech, Florian simply, was lurking there behind, working on something, and suddenly he comes out and puts out a slide like, "Why don't we use large language models for the translation?" So I mean, there were mixed feelings about it, but I liked the idea. So I grabbed it and we just ran with it. Yeah, so I wasn't feeling like, leading a team on something I'm not working with, which were large language models. But Najeeb, actually, he told me that there is no way to go out of this. So, so I have to do it. Yeah. So, and I'm here. And so this is broadly what are the scientific topics of the problem. And we bring, as I said, ideas mainly from speech. And there's the diagram of WAF to WEC approach, which we are already working on, mostly with Karahan. And of course, he is supported by the team from Istanbul, Boğaziçi University, Murad and Lale. And so it's starting to be something like Sign to WEC. Also, there is, the NLP, the one that I'm not really an expert in. So I brought some people to help us with it, and I hope that other teams will also, bring some nice ideas. So it's just the bird image there, but there is a lot of stuff. And I've also added the rack diagram because we have some ideas what to do with it. And of course, then there is vision, and in vision we use either the masked representations with masked autoencoders, but also Dino for the self-supervised learning approach. And yeah, the team is divided into several groups. I divided them mostly by their, let's say, their origins or their institutions they are coming from. So we have the Czech teams of me, myself, then senior member Ivan Gruber, and junior members Jakub Straka and Tomáš Železný. So we are mostly doing computer vision in our University of West Bohemia. And yeah, then there is Murat, Lale, Karahan, and Bolaji. Bolaji will not join us in person. He will be remote. And yeah, they are mostly like linguists, sign language recognition, also computer vision, but also before that, a little bit of speech, yeah, or a lot of speech, let's say. Then there is Chester, who is from Chicago, what was the pronunciation? Yeah. And he actually does sign language recognition, computer vision, and he brought some very interesting idea. He's the one that brought the idea of Dino being in there. Then we have local people, Kevin and Chuan, which were doing at the time some sign language recognition. Also, they do NLP, and with Chuan we had like really long and frequent discussions. So we had weekly meetings, and Chuan actually put together the pipeline of Lava to make it work, and so this was very productive. And Kevin is also very excited to be with us. We are talking about lots of ideas, and we were discussing also this rack idea for our approach. And then there is Jiří and Dominic from UFAL in Prague, who are mostly there for NLP. And also Jiří likes to do applications, so he will be in charge of the demo application for our project. I mean the application is in apps, not like filling out the applications for this workshop, which is also a tedious task, by the way. So yeah. And then there are some undergrads. I just put them together. Andrzej and Václav from Pilsen. Richard is here as the undergrad that proposed from Hopkins. And also Alessa joined us. Where is she? Hi there. Oh, you moved. Okay. Great. Just so she's also undergrad. She approached me in the beginning whether she could, do the project with us, and of course I agreed. And in the 2 weeks of summer school, I found out it was a great move from me because she's really, really talented and knows a lot of stuff. So I think she'll bring a lot to the team. And also 2 names are bold in there. In a bold is Karahan and Richard. Maybe you can, have a guess why they are bold. I mean, in text. Probably no one is trying to. Okay. So it's because they actually know sign language. Yeah, so it's a little bit different when we are doing speech recognition. You usually know, the language you are trying to, translate. In our case, we just simply don't know. So Karahan knows a little bit of ASL, but a lot of Turkish sign language, and Richard, of course, knows LSA. And yeah, if you've been here through the summer school, you know we had also some conversations about this. And so what we want to achieve is just a reminder, we do sign language translation, which is straight from the video to the text. So no glosses in between, it's called gloss-free, or we can say or even gloss-less approach, because normally we would first, detect the individual sign, recognize them, and then try to do text-to-text, translation. So we are going, end-to-end straight away. This is our data curation sheet. So there is a lot of data sets. I'm just putting down the continuous sign language data sets. And the most important one is the YouTube ASL, which is a collection of 1,000 hours from internet, from YouTube. And they are, not that well aligned, so only loosely aligned captions to it, but we can use it mostly for pre-training. And just few days ago, or maybe 1 week ago, the YouTube SL 25 came out, which is 3,000 hours of multilingual data. So we will have a look at it and use it probably mostly after the workshop to test some multilingual stuff with it. So this is like our main approach of what we want to do. I also created a small, I don't know how not copyrighted the image of the llama is, yeah, but the hands are mine. So let's say it's 50-50. And so this is like the idea of lava. If you read the paper, it's just about tuning visual features to the large language model decoder. So it's in the same way we are going to approach this. So we have at the input the video and then some encoder, which will be based on poses and also masked representations via mask autoencoders, and also self-supervised learning via Dino. And yeah, and we just want to try whether it's possible to project them to the space of the large language models to be able to do not just translation but other tasks. And also the idea with the RAG is there, which is a new one, and so actually we want to have some similarity measure as in RAG, but there are two possibilities how to do it. And I'll explain a little bit later if there's time. So here's just a quick diagram of what we did for the post pre-training. So it's actually just the, straight masked representation learning. When you get your poses, you mask them and you are trying to reconstruct them. And then, you freeze the model and use it in your recognition task with the decoder. So we tried this for isolated sign language recognition, and the results were as in other fields. So you get to your best recognition rates faster with a pre-trained model. In some cases, you have even better recognition rates. And
So, Mark, can I interrupt you a quick question?
Yeah, sure.
So that pose estimation, what is its output? Is it like a bunch of fixed joints and you have the position and orientation? What are those vectors? Or is it something more abstract?
Yeah, so it's just the positions of the vectors. I've presented it in my talk, so I just didn't want to put it here. But yeah, but there's a pose estimation. It's just the framework that returns positions in the XY coordinates from your image. Yeah, sure. And you can draw them, and they make sense. And it's usually in the place where the joints are, where the stationary thing is and the thing around is going on. Also, we have some facial landmarks. Yeah, and we discussed it during my talk, so I just haven't put it here. But yeah, so yeah, those are those. And we are actually using then some kind of embedding. So it's similar when you have sparse representations, but this is dense representation, right? So there's actually a linear layer that projects it to the space of the transformer. Spotter 2 is the Spotter 1 was the paper we did with my undergrad student, and yeah, so it's just a simple transformer. Yeah.
And here position means time, not spatial position.
This one?
Yeah.
Yeah, that's in a sequence. So yeah,
So
that's
temporal encoding.
yeah, temporal encoding. And interestingly, we found out that when you omit the positional encoding for isolated sign language recognition, it actually does not hurt the recognition rate that much, which is a bit surprising result. So meaning that you can, shuffle these as you want, and you still get the right class out of it. I mean, right in 70% of the time or something like that. So that was a bit interesting. So my hypothesis is it's just because it's the isolated version, yeah? So you can shift the frames around and you still get the hand shapes, you get the positions. Yeah, so it works. Okay, and this is the masked autoencoder vision pre-training. So it's the version of masked representation learning when you just, there are many talks about this. So I quickly just remind you, you just mask patches of the images. The different style, for those who were not here, is that you are not inputting into your encoder the whole mask sequence, but you are using encoder to encode just the visible patches, and then the decoder, which is not present in standard NLP pre-training tasks, the decoder inputs also the masked tokens there. There are the learnable masked tokens, and tries to reconstruct the full image patch by patch using just simple mean square error. Okay, and we are thinking about this idea that in the case of sign language, as I was talking also in my talk, my lecture, we lose a lot of details in the hand shapes and so on, and mostly when you actually mask for example, both hands. So it's very hard. For example, you can see it in this image. It's very hard for the model to reconstruct the exact shape. But if you mask only part of the hand or just one hand, the model has more easier time reconstructing it. So we are thinking about the idea of doing some, yeah.
Just to make sure everybody understands what they're looking at, temporally, the images on row 3 were created first, and then they were masked to get row 1, and then reconstructed to get row 2.
Yeah, so this is like the image showing you that these one are the ones that were reconstructed. You see?
Yep.
Or no, sorry, not reconstructed. Yeah. And here is just you use the original ones to put it here, yeah? So when the reconstructions happens, it happens also on the visible patches.
Oh, okay. The original photos are not here.
The original ones are not here.
I was wondering why the last row is so blurry. Okay, now I understand.
So the last row is just you substitute the reconstructed ones with the original ones so that it looks better.
Yeah, got it. Okay, so the third row is like the first and the second rows overlaid.
Yeah, like a combination of these two.
Yeah, got it.
But sure, it would be maybe, it should be, it would be better if the original images were there. It's just they would not, fit the slide. Yeah, but this is how they interpret the results in the original paper. So it's just a copy of that procedure. Okay. So in this case, it would be maybe like a good way to do some intelligent masking. But I've also discussed this with Florian, and in many cases, it has been shown that the randomness actually is better. And also, it's not important in this case how the reconstruction is looking to us, how it seems to us, whether it's good or not, but how the representations behave, right? So this is just to show that the representation learned something that is capable of reconstruction, but they might be not important, to reconstruct it by pixel precisely. We just need them to do the work in a translation task. So there's another perspective on it. Okay, and then the Dino. So it's the self-supervised learning, and Schuster already has, a paper under review. So they got some really good results, and these images are from his paper. So what we do is we take the multi-queue approach, and we split the image into the hands, left, right hand, and the head. And then there are two models. One is for the face, which learns just from the faces, and the other one is for the hands, and there is a shared model between the hands. And we believe that this description will capture the fine details in the facial expression, in the shapes of the hands, and so on. And also, Chester's results are very promising, and yeah, and it takes really not that much resources to train this compared to other approaches. So this is the idea of it. I was explaining Dino in detail in my lecture, but generally you have teacher-student, as it is in self-supervised learning, and you have some global views for the teacher and some local views for the student. And yeah, the student is trying to do the same recognition as the teacher, but also the teacher is learning from the student, yeah, in some averaging manner. So this is for the Dino. And then we have this sign to VEG approach. So it actually follows the WAF to VEG approach, where you are trying to learn some codebook and then use some, clever stuff like differentiable softmax to learn them. Then you get your latent representations, and you want to quantize it, in a time domain. So that some generic, let's say, movements or atomic movements and behaviors of hands and face are learned and quantized to be represented in one vector, let's say. So Karahan is already working on this. He has the pipeline ready. Yeah, and then for sign language instructions, the instructions are important. So here are just a few examples. Like these are the tokens that will come from the vision models. Then there'll be some separator and then some instruction what to do with this. So let's say the basic one or the simple one would be like translate the given sequence of sign language, features into English, and then the target will be the sentence that is in the data set. But we can also, ask it different questions about the tokens. So we don't just, we will not just learn to translate, even we will do this as a first step because it's the easiest one. But then we will analyze the data in the data set, and we can, generate questions about the translations. So, for example, if there's a sentence that I went to the shop to buy some apples, we just can instruct it like, what does the person want to buy? And the answer would be an apple. So this is an important part of it, to do also this instruction tuning. And also we've, as in translation is usual that you have like several translations for the sentence. So we are now Václav and with the help of Ivan, or Václav and Ivan in American pronunciation. So they have already coded it to use GPT to analyze the translations and provide us with some other forms of them, so that we have like more training data. Yeah, and the retrieval augmented generation. I'm running out of time, so I will be quick. So we want to do one idea is do vision-to-vision similarity measure, because for this we do not need to align the vision with the language, right? And we can just find similar videos in our data set and take the texts that are associated with these videos, their translations, let's say, and use this text as the context for the large language model. So it'll be, I think, hopefully it's a new idea. I haven't seen it, but I'm not very expert in this field. So it will be something like multimodal RAG system, let's say. And of course, you can try text-to-text similarity measure, where we would take the the tokens of the sign language tokens after the projection to the large language model, and try to find whether there are some similarities in our textual data set. And for this, we would need to actually align. I think we will need to align. It will not arise by itself, I think. So this is maybe an idea that will be implemented only after the workshop. We will start with the vision-to-vision similarity, which is easier. And this one is from already published paper. They do this interesting stuff because this is a form of a clip model, where you have your video of the signing. You have this visual encoder, which we are going to have ready. So then we can play with it later. I mean, if the time plan is good, we can manage it during the workshop, but maybe we'll do it after the workshop. And then you have this text encoder, and you just put it in the clip scenario where you wanna maximize the similarity between the text and videos that are together, and you want to minimize the similarity of the ones that are not going together, are not the translations of the videos. Okay, so for the evaluation, I really have to go faster. So there are some standard blow, rogue, and so on, but we don't think that these are the only important measures for the success of our model. So we also want to build like a decision-making instruction accuracy measure. So whether we will design some yes/no questions for the sign language and automatically create a dataset from the transcriptions to ask simple yes/no questions. So either was there a specific sign performed, yes, no, or is the person talking about weather, or things like this. And then we are thinking about some human trials, which are always hard, but at least we have Richard that can be one human trial, and then we can set up the scenarios and make it larger after the workshop also. So this can be an ongoing thing. Okay, so in just the overview. So what we have done, we have prepared the critical data, we have the model architectures designed, and the pipelines are ready. So the pre-training has been implemented and trained on a portion of the data, so we will continue to pre-train more and more. The quantization has been implemented, and we will play around with it some more, because we have some other ideas how to combine dyno features with the quantization, which could be interesting. And also we did the sign language instruction tuning pipeline with Llama version 1. So this is the setup from Lava paper. And what we will do. So of course we will prepare more data. I think we have the critical data ready. So this is just to have more data. More data is better. Continue with the pre-training quantization, and also we have to switch the Llama version 1 to Llama version 3. So that'll take some time, but I think it should be doable. And then we'll focus on the RAG experiment as in a proof of concept, so see whether it will actually benefit us a lot or not. And of course, we want to build a demo application of sign language translation. So we will input a video and it will output a text. It should be a web-based application so that we can show it around a lot. Okay, and I think that's it. So I haven't mentioned anything about the meeting, so just quickly, I thought that Sanjeev, you will talk about it a bit. I sent you some nice photos. I was hoping you will show them, but I don't have it in my presentation. We meet in Prague, in April 27 and 28. So yeah, people liked it, I think, and we discussed there a lot of critical things, and most importantly, the dyno idea came from there, and I think is one of the best vision ideas in this whole scenario. Okay, so thank you.
Yeah, we have time for questions. Thank you. Let me start with one. So you mentioned something about evaluation.
Yeah.
You said blue, rouge. So I guess I'm familiar with how machine translation is evaluated, and they look like measures for that. How have people traditionally evaluated sign language recognition? Is it just classification accuracy? And
it's blow actually, the blue or blow score. It's the most used one, but I don't think it's the proper one.
Okay.
And even if you read some results, yesterday I was reading some papers, and I know German, so but maybe Philip could help me with that. But I think that they actually misinterpreted a result when they showed that, look, we are translating it good, but the other model is translating it wrong. And I think they had it around, so so yeah, but it's the problem with Phoenix data set. It is in German, and a lot of people do not speak German.
Okay. Other questions? Yep.
You were talking about the sign to vec model. So we are going to have some embeddings for the sign frames themselves because we could use those for the rack. Right?
Yeah, sure,
No,
sure,
not
sure.
only
So
visual.
what was already done is that you have these pure posal vectors, let's say, with the coordinates, normalized coordinates of joints, but we want to play around with it. Yeah, so we want to put different representations of sign
Okay,
language.
so I just had the
inside.
idea that we not only have visual and textual, but also like sign vectors for the rack.
Yeah, yeah, sure, sure.
Right.
So we all discuss it, you know, in our team.
Great. Any more questions? Okay, Thomas, just a moment.
Thank you. This is really interesting. So just want to address the elephant in the room in the sense that there are a lot of now multimodal models out there. Do you plan to also evaluate and compare with a commercial system? I saw that demo from OpenAI GPT-4o, which seems to do everything, which I don't believe it might be able to do that. But
so we played around with it a bit, and it actually had some really, really good recognition of signs until we found out that the name of the sign is the name of the file. And and as soon as we renamed the files, it stopped working and it was like producing randomness. So we might do that, but I don't want it to be like the focus because yeah, it seems to not be there yet. So
yeah, actually, I think the systems behind an API are not really helping research at the moment. So what you're doing is certainly helping the community.
yeah, that's
right.
Yeah.
Thank you. One more. Okay, going once, going twice. Thank you, Marek. Yeah.
Thank you.
John? I'll change the slide.
Yeah, I don't know.
Yeah, I don't know how to do this, but it's okay. We'll just pitch it here. You may want to give that a refresh if that's okay.
Oh, okay.
Sorry.
In that case,
Or if not, it's fine too. There's no dramatic change. Just change the
you know
word.
what, let it be because
Yeah,
I'll
that's
have to
fine.
open my email and
Oh, let's not do that then. Yeah. You got a local copy. Okie dokes. Well, yeah, good morning. So I'm pleased to introduce the LLM performance evaluations in research astronomy team. So this is a bit different than some of the other teams, but we're really excited because this is a very multidisciplinary effort. So I just wanted to showcase, our team members here. As you can see, we have, a very diverse team here, and also we have quite a few senior researchers, although I should mention some of the names are italicized. Those are folks who will only be here part-time or maybe you might not see them as much. But rest assured, they're all local to Baltimore, so you can hunt them down if you want. Just to give a quick overview, so my name is John, and then two of my co-leaders here are Joe, who just arrived from Australia, and Kartik Iyer, who just took the train down from Colombia. They are fellow astronomers with me, so we all have PhDs in physics or astronomy, and as well as probably the majority of our team here, right? So in many senses, we're newcomers to language technology, so we really do look forward to getting to know you all and leaning in on your expertise. I think that it's also a good opportunity for us to really learn more about different modalities of thinking, kind of creative problem solving in ways that maybe astronomers or physicists think about problems, and we can also learn a lot, I'm sure, from all the prior art that's been done with the rich history of JSALT, and that's being done here at Hopkins. So other senior leaders include Anjali and Philip on our team, and then Sanjeev Sharma, who's another astronomer at Space Telescope Science Institute. Josh Peak, Michelle Namaka are members of the Data Science Mission Office at Space Telescope Science Institute. And then Jen Kotler is on parental leave, but she also contributed a lot to the early work here. And then in terms of grad students, we have Elena Baral and Mikhail Yunus. And then in terms of undergrads, we have Alina, Kiara, Charlie, and Christine, who are coming from all around the world here. So again, we're really excited to get started on our work. And in fact, we've actually begun with a bit of an experimental design that sort of hybridizes the work that you can do with LLMs with front-end interfaces on Slack, and this notion of evaluation, something that we astronomers don't think of a lot. We just have generally a single ground truth, and we sort of roll with that. So in terms of the experimental design, the goal is to understand how do we evaluate LLMs as an assistant for research, for astronomy research specifically. The reason we're interested in astronomy is partly because the data are all open. They're effectively worthless. You can't really monetize it. Every now and then, a government agency will come and say, oh, you saw something that you weren't supposed to see up in the sky. Please erase that. But, in general, we don't get too many of those requests. Well, I wouldn't be able to tell you if we did or didn't. But anyhow, in general, they're pretty open, and the astronomy community has this sort of widespread notion of an open skies policy that you really should share and archive your data. So Space Telescope Science Institute up the street from us here is one of the world leaders in that, and we do serve up a lot of the data in the archive there, one of the biggest astronomy archives in the world. And so with that kind of data, we're thinking, how do we also facilitate the use of large language models in research astronomy? So maybe you want to have something that can answer astronomy research questions for you. So there's a question up sort of in the right side. How can compressed sensing be used for image deconvolution and radio interferometry? This is a question that's near and dear to my heart because I worked in radio interferometry. I actually spent some time in South Africa helping to commission a telescope there called Meerkat. And it gives, you can basically have a chat bot, which is hooked up to GPT-4o in this case, that can also consult a corpus of archive papers, basically try to evaluate or retrieve some similar papers that are relevant to that prompt or that question, and then basically give this response with citations. This is kind of the goal of what we said we wanted to build during the pre-work stage. And in fact, we did build this. This is now a live system that operates in the Space Telescope Science Institute Slack, which is a workspace with 800 or so folks, but of which only about 150 or so are actual astronomers. Most of them are actually software engineers and outreach specialists, folks who work in other domains. So we basically wanted to bring this into the Space Telescope Slack as a way to allow other astronomy experts to actually evaluate and basically test the system, build trust in the system, and so that we can really go and evaluate how the community is using it. And we also don't want it to necessarily go off the rails and talk about other sorts of things. So I have this kind of random prompt here. How do I get my bird of paradise plant to bloom indoors? And it's not supposed to answer for that sort of thing. One of the interesting things about this prompt, though, is not only that it should, or about this entire system, is that it should not only cite its sources reliably. That's one of the things that we really wanted to do. And this is one of the things that we already are finding a lot of room for improvement. But we also want to be able to record feedback and data annotations by the same community that's using and testing this system. So the way we've set this up is that basically the server on the back end is recording emoji responses. So if people are reacting with a thumbs up or thumbs down emoji, that's recorded and treated as user data. Those data are going to be anonymized and then actually published alongside sort of our experimental design. So the RAG part of this is actually pretty simple right now. I think, again, just even based on the last 2 weeks of lectures, I think we have a lot of great ideas on how to improve this. Like, for instance, hybridizing BM25 alongside something like a similarity search in the embedding space. But this is just sort of your typical RAG system where you're taking your query, throwing it in against our archive, paper list, which is just living in some vector database somewhere. In this case, we decided only to match similarity on archive abstracts from the AstroPH listings. So AstroPH is the listings under physics, which are only astronomy papers. There may be some that we missed there that are relevant, so this is something we have to rethink. But one of the kind of nice things about archive paper abstracts is that they're like all plain text, more or less. You don't have a lot of like LaTeX commands and stuff like that that you have to sort of parse out or clean. And you're hoping that that the authors have already done a good job of summarizing your paper for you. So we're kind of like being lazy here. Of course, we try to spin this whole thing up in a couple of weeks this spring. So of course, I think there's also room for improvement there. But upon matching to some relevant archive papers that are similar or hopefully relevant to the user query, we then go and grab some other useful metadata and then concatenate that on the prompt and you do your usual RAG business. And the fun thing is that, so we wanted to like standardize what our experimental setup would be before we like release the data. So we actually did kind of crunch together this paper really, really quickly. And just it's sitting on archive. So if you're really interested in some of these details, these are public now. And so a heroic effort by the team for putting this together. So I really wanted to thank our group. I think we've been gelling really well, and it's really motivated by these sort of goals, of these concrete actionable goals. Also, many thanks just to the CLSP team for supporting this work. And just to kind of rehash this data collection phase, what we're doing is putting together some basically a database, right, with a couple of tables of all the recorded data, where we want to be able to use these for different modes of evaluation. So at the heart of what we're trying to do, it's really question-answer pairs, right? We're getting scientific queries. Hopefully those queries have useful answers, but we're going to basically grab an answer that comes out from the LLM, which is being passed through the Slack bot. It's only single turn conversation, so as of now, we're not really able to have it go through and basically continue to respond to any other questions. It has no memory there. But it is able to record these reactions. So I've kind of color coded them. I know it's a little bit hard to see, but sort of the reds are the Q&A pairs. The reactions are things that are recorded that we think might be useful data, right? So how many reactions, what the reaction type is, those kinds of events. We've sort of given instructions that users should give a thumbs up if the question, if their scientific question is correctly answered, right? And so we want to be specific about that. Of course, users kind of have their own ideas of what they want to do. They, put in random other emoji reactions for fun. They do all sorts of other stuff. So we're going to obviously have to clean and kind of parse through this data. That's all good. The other option is that, the users can actually give feedback here. So they can also say things like, okay, this is all great. I think some of these citations may be wrong, or maybe this wasn't the most recent result. I think there's more up-to-date things. We can get more fine-grained feedback. And obviously that makes the data a little more complex. So I think that what we are going to have to lean into as well is more of a qualitative understanding, in addition to a more quantitative establishment, way to determine the metrics here for evaluation. And then finally, we're also recording, obviously all the retrieved all the retrievals here. I should say a little bit about the models that we're using. So right now we're using GPT-4o. We've tested that the system works, just fine with like Llama 3, 8 billion instruct or whatever, and any of the other open source models. So depending on our appetite for only sticking to open source development, we might kind of just finalize the end product with only open source models. They seem to be doing pretty well. On the retrieval side, we're also doing just a simple, like a small model, BGE English version 1.5. And so those are kind of what we're working with here. But of course, we want to improve the retrieval. I think that's one of the sort of biggest limitations of the current setup. But for now, we're keeping track of all these sorts of things, the retrieval scores and whatnot. And this is allowing us to also do evaluations on just the retrievals part. The other thing about the experimental design is we in the Slack workspace, we have, again, many astronomers, again, all people with PhDs in physics or astronomy, who are interested in doing, they're actively doing research in astronomy. So there's a question of like, what kinds of questions are going to be asked, to this LLM? And there's actually, we'll talk about this in more detail, I'm sure, as throughout the upcoming weeks. But there's kind of like a phase of building trust with the LLM. A lot of astronomers, are a little reticent to use these kinds of systems. They're a little bit unsure about what are good questions, what are good queries to ask, or ones that will get good answers. And then there's also, questions about like actually using this in like the real world usage. Whether people are going to start doing literature reviews or doing kinds of things like that with these things. We sort of have noticed that different people have different levels of expertise or willingness to use such a system. So I think that's going to be a key part of our evaluation. We also have a mode not only in this public channel where everybody can talk together to this LLM and respond. So you can have a user 1 ask a question, user 2 might give an emoji response, and user 3 also gives an emoji response. And the user 1 goes back and says, oh, I actually didn't like this answer, and then writes that in. So this allows sort of, again, the way we do the evaluation here is going to be kind of complex because of the way that we've set this up, but it enables both that mode of interaction as well as another mode of interaction in which you can directly message the Slack bot in a private space. And you might think that people have different kinds of questions that they would like to chat with an LLM about in the direct messaging space. Jason, do you have a question?
Yeah.
Oh.
So if I understand right, you're doing single turn question answer, is that right?
Yes, for
not
now, we're
dialogue.
doing single turn.
And so a response in the channel from a user is not actually seen by the language model. It's always evaluation.
Exactly. So that goes in basically right here into this table of feedback, which is for our eyes only.
Yep. Are you thinking about extensions to follow-up questions? I mean, my experience using LLMs is often their first answer needs some adjustment.
Yeah, for sure. We are definitely considering that. I think it makes it a little bit trickier to understand, like to determine how we're going to do the evaluation in a more quantitative way. But I think that that's on the table. I mean, you'll see in a moment. We have a load of ideas to follow up from now. But yeah, thanks for that suggestion. Yep. And so as of end of last week or so, we have I would say a relatively compact data set. So we have, I think, 43 users who have signed up. So again, 43 astronomers who have used the system. They've put 378 queries, and about more than 2/3 of them are in the group channel where everybody can see each other's responses, and then about 100 of them, so about less than 1/3, are direct messages. I actually didn't realize that there were so many direct message ones because I can't see them. So it wasn't until I scanned through this database to see that there are a few there. People have been okay about giving emoji reactions. Usually you're not getting a ton of feedback there, but you can sometimes you can infer this kind of stuff. There's a lot of things that we sort of are trying to infer from the data. And so actually one of the things that we've put in just to the IRB, which by the way, we had to get IRB approval for that. So big thanks to Anjali Field for starting that process. But we're kind of doing an extension where we actually want to conduct an interview study as a follow-up. And so hopefully that will be approved soon. And then from the emoji reactions, from the feedback or whatever the comments that users are leaving, obviously we can sort of make up our own ideas of what the users are thinking. And this is not that hard to do because these are like my colleagues, right? I have some pulse on what they're thinking, but we should do this in a more systematic way, hence the interview studies. And then so we have a number of those pieces of data, and then we also have these retrieval data. So you can actually see the number of retrievals does not equal the number of user queries. So that indicates that there's some failures in there. So that's another thing that we need to go and fix up. Okay, so what exactly are our goals? Well, I mean, we've already laid out this experimental design, and we have a live system. So I've been kind of calling this phase 1 of our experiment, which I think has been a huge success so far. We're going to want to anonymize that data. I don't think it's going to be too cumbersome given that we have fewer than 500 responses in here. We have, oh, by the way, we have these subteams: data evaluation, generation / Slackbot / LLM, and then the retrieval side of things. And everything is kind of, like that we're trying to do is kind of a mix of each of these teams, obviously, but it's good to have some structure in here. We're going to certainly want to evaluate the framework paper with that anonymized data and submit that to a conference, probably I would say within July. I think this is an achievable goal. And then we're going to want to do both qualitative evaluations with the interview studies. So pending, training and IRB reapproval. Hopefully we'll get underway with that with the Space Telescope Science Institute employees. We need to develop rubrics and sort of guidelines for exactly how that's going to go. We've also been chatting with some other folks here, some of the HCI faculty, so like Jiang Shao, I think, who's interested in being more involved here. We're also chatting, about how to develop more quantitative metrics from emoji reactions. And so I think that's going to require a little bit more thought because we have a small corpus of data. So so putting that together is it's gonna be interesting. We're gonna have we might like lean into using other LLMs as judges. We might try to do something that's hopefully more maybe something that's simpler. But I think that's going to be one of the big pushes here, obviously, because we're trying to actually do evaluation as part of the title of our project. We've already put out actually a GitHub repository with everything, but we're also going to want to like basically have our finalized form of what the evaluations are. So anybody basically can run out this, can deploy and serve up their own version of this if they really want. It's really not that difficult. And then finally, in terms of evaluation as well, there's also sort of the question of how do we more quantitatively evaluate the retrieval methods. So I think that's another sort of thing that the retrieval team is going to focus on. We also have a load of stretch goals, even just in the last couple of days, chatting with like many of our team members. I think there's a lot of interesting follow-up there. For instance, one of them is to create an extended data set of expert annotated data. So just again, people like for many of the astronomers on the teams, we already kind of stress tested the system with the sorts of questions we would ask, and those data are useful for evaluation for sure. I mean, it's a little bit biased, obviously, because it's not the same. But having those kinds of questions where we sort of know how to ask good questions and whatever. And then I think there's also the problem of like having I think there's two problems here. There's how do you educate users to appropriately or effectively use such a system, and then there's the questions of like once they sort of gain familiarity with the system, how do they best use the system, and how do you know that this is working well for the team? So creating either synthetic data to really like rapidly increase the amount of data that we have based off of like an initial data set from within our team. That was something we talked about during our planning meeting, and then performing evaluations on those. And then the other thing is that right now we haven't created a system that really like can learn preference data. So if we want to do something like reinforcement learning, then we're probably going to have to adjust our experiment again. So we've been talking about this sort of potential phase 2 of the experiment where we're sort of changing the exactly like whether we're doing A/B testing with LLM responses or doing other sorts of add-ons that includes multi-turn conversations as another example. Those are kinds of things that we might also add into this in order to sort of more sophisticated evaluations on that data. Yeah, so I think that's it in terms of our slides. Again, we're really excited to get cracking on this. Thanks for listening.
Thank you. We have time for questions or comments. All right. Almost again.
Okay, thank you. This sounds like a really awesome project, and evaluation of large language models capabilities, I think, is really a top topic. So I did not completely understand. So this Slack channel will be created or is already created, and how are people actually instructed? Because how you prime participants is extremely critical. Any thoughts on that?
Yeah, I mean, so to answer your first question, this has already been created, and we have already started recording data with the astronomers. So this is what we call phase 1, and this started about like near the end of May. So they've been this is over a couple of weeks of experimenting with the system. Users are given, so it's a Slack channel. You can sort of pin a few messages or instructions. We also had users all sign a consent form, which obviously had, in addition to the standard, boilerplate consent stuff, there's also like, there's two things I failed to mention. One is instructions on like how do we want you to use the system, like ask scientific questions and then give an emoji response, and if it answers your question, and also give this kind of feedback. The other thing we actually also collected, I failed to mention, is demographic data. So there's sort of optional demographic information. Almost everybody was willing to contribute that, so we can also try to understand some of these things and how they vary with demographics. But in terms of priming the audience, I mean, if I were to go back, I maybe would have given more fine-grained instructions, or maybe like blasted everybody with the same instructions every single day so that they remembered it, because you can definitely see that the sort of users it's very hard to herd users into a particular mode of interaction. they're going to do what they want. Like some of the users want to jailbreak the system, like no matter what you tell them, like stop trying to ruin this, and they're trying to like get them to, you know, this thing to write poetry or crack jokes or something in Spanish, and like it's just all sorts of like interesting ways that users are interacting with it. So I don't know if there's much more that we could do, but we did give like a common response.
Sounds like a real world project.
Thank you.
So one thing, are you planning to analyze it over time? So how user behavior might change?
Yeah, for sure. We definitely do want to analyze this over time. Again, it's not a huge amount of data, so I think we're going to have to be kind of careful with what our interpretations will be. But one of the, you know, we have certain hypotheses, right? Maybe like within, you know, the first few days or something of joining this channel, there's going to be sort of a batch of like really wild card questions, but then at some point it'll settle into a steady state of like understanding how to use the system. Another hypothesis was that because we have both the private direct messaging and the in-channel, the group channel sort of options, that, you know, if people were in the channel and they could see the other people asking kinds of responses, that maybe like kind of collectively the group of astronomers would all sort of trend towards better usage of the model rather than falling, you know, into certain traps. Like there's certain traps which like this thing will perform really poorly on, and it's, you know, and it's interesting to hypothesize like maybe people will avoid those kinds of things collectively and gain, you know, an experience on how to use it.
Yeah, I think this is a sort of adaptation of the user to the system. Yeah.
Yeah. Which I don't know if that's
Well,
good or bad.
that's
Again,
real life.
I'm not an HCI kind of researcher,
Okay.
but I yeah, we do have those on our team, which we're really happy to.
Thank you.
Yep.
Yeah. No, Thomas asked an interesting question, which I think might be worth thinking about. We'll think more through the summer. One of the things that might help is to talk to people who worked in information retrieval for a long time. So when they create queries for testing search engines, one of the things they emphasize is they want to bring in real users, and these people ask for things that they're really looking for. And it's not that, hey, here's the like, you know, LLM, think of something to ask it, right? And you're conditioning what you want to ask based on your expectation of what the model is able to do, rather than something that you really want, right?
Yes.
And so there might be some lessons over there. So for example, to say to them, hey, ask for things that you actually want to get from the archive or something like that. And don't worry, like, you know, this is a prototype, so it may fail, but that's what we want to learn. So don't just think of a question to ask. Ask something
Right.
that you wanted to ask anyway, or that's on your mind today. And the other reason it's useful is because when you do that, I'm going to walk to Jason so that I can give him the mic next, is that when they do that, then they're able to assess the answers more accurately because they did have a real need in mind, and then they can see if it met that need.
Yes.
Right?
Yeah. And I think over time we're seeing more of that. Like definitely the initial questions are like, can this thing cite all my papers? You know, people ask the sort of standard, like just test, you know, testing the system. But then after a while, you can kind of tell, right? Like people are asking questions which are like the real research questions, or maybe they're sitting in a talk and they heard somebody make some claim. They're like, oh, is this really true? Let me go and ask this system. And those are the kinds of things that we're seeing crop up sort of later in time. So there is actually a temporal element to
there's
this.
definitely a temporal thing. And also, as the system performs better, people's questions become deeper.
That's a good point. Yeah.
All right, Jason.
Thank you.
Sanjeev is encouraging you to make sure the users are giving you enough breadth by not limiting themselves to what the system can currently do. You might also want to encourage them to give you depth in a few hero scenarios that you think are especially important. I'm writing a literature review. So if you had like lots of questions from people who are writing literature reviews, or, you know, other particular types of questions, types of use cases that you think are important for the LLM, you might be able to get dense enough information, dense enough examples on those hero scenarios that you could evaluate how well people will be able to complete that kind of task.
By dense, do you mean lots of responses to the same type of question? What do you mean by dense?
I mean, lots of examples of the same type of question.
Yeah,
so depth, and you were talking about breadth, that people shouldn't limit themselves to a few things.
Thanks.
Other comments or questions? Oh, yes, Alina.
I think a lot of people might be curious. So when user interacts with the shared environment in non-direct messages, can other users see who is asking question, or are they all masked?
No, so they're, yeah, right. So the anonymization will come when we publish the data and yeah, I guess for people analyzing the data too, if they're not already on the IRB. But it is in a common channel. I mean, it's in a private channel, so you have to fill out the user consent form in order to join, but everybody can see each other's questions. So we expect that to change the dynamic.
Right. One more. All right. Okay, let's thank John for the presentation. Thank you, John. And let's now take a 15-minute break. Stretch your legs. There's plenty of good food. Please eat it. And we'll be starting again in 15 minutes. Right. So local people, take it easy. Online people, come back in 15.
Yeah, are we getting audio?
Say something again, Jason. Check 1, 2.
Now is the time. For all good researchers to come to the aid of their society. All right, so I haven't worked before on AI for social good. The other senior members of this team have, but we're looking specifically at social good in an era of social networks. So very basic question about how to organize a society to promote democratic discourse. You've got lots and lots of people. Some of them probably have good ideas. Can the good ideas be found? Can they rise up? Will they be noticed? Because there's so much other stuff, people repeating themselves, as well as people saying things that are unhelpful or even false. And what's the incentive for people to share their ideas anyway if they're probably not going to be noticed? So they might not be noticed because the people who need to read them are only interested in other stuff. Somebody's on their in their left or right wing filter bubble and doesn't see correctives that need to be administered. And if they do see them, they might not take them seriously. So as Andy Perrin on our team, a political sociologist, will tell you, we all have tremendous defenses against having to accommodate ideas that would cause us cognitive dissonance that don't jive well with our current worldview. So here are some of the defenses in quotes, and you'll see this all the time. It's irrelevant. You post, there are thousands of people with this problem, and somebody writes back and say, well, it's probably under 20 per year. And you're like, well, even one would be too many. We all do this. It's not just the other side. We do it too, whatever the other side is. I'm not presuming that we're all on the same side of anything. But it used to be when I was growing up that there were 3 television networks, maybe 4. There's a public TV network also. And they were all trying to appeal to everybody. So there were all kinds of centrists and everybody trusted them. So it's great that we've gone to this world that in theory allows stuff to bubble up, what people called in the early days of cable, the 500 channel world. But it's a lot more than 500 channels now. And the result is that everybody has to figure out who they trust. And we're all getting fragmentary views of the world. So many voices means that there's a loss of any kind of centralization or accepted authority. And this means that there's fragmentation of the discourse. So our question is, can we re-architect the media to try to bring things back together again, to try to show ideas to the people who need to see them? So we want to reduce polarization. There are sites that try to do this already. They are basically frequented by debate geeks, people like Wikipedia editors who are interested in seeing all sides of the issue. So this is a screenshot from Kialo, which has a debate tree. Here we're a few steps down here on a question of is eating meat wrong? And here we have an opposing claim and then something that agrees with the opposing claim, and then children of that agree or disagree with this argument. So we've got this great tree. People are curating this debate. You can see them discussing it over here. That's great. Nobody goes to this site. They have an educational branch for using it in the classroom, but we have to meet people where they actually are. So why are people conversing on social media? They're doing it for all kinds of reasons that have to do with their friends, their enemies, and killing time. So I've listed some here. I listed this last one here, seek information and constructive discussion. I put it last for a reason. That's not why most people are there. A few people maybe some people in this audience, because if you've studied the scientific method, maybe you've absorbed the value that you should go out and seek things that you don't know and don't agree with, in that they might correct you. But even if it's rare that people are looking for this, if you're watching the Super Bowl or you're hosting a party for the Super Bowl, there's lots of caloric, sugary, salty things out on the buffet. Maybe you'll put a tray of vegetables there and somebody will eat a few vegetables and it's better than nothing. So it's the least we can do to at least try putting the nutritious stuff out there. All right, so what does social media look like? The interface is remarkably common across different sites. So what site is this? I heard some people say Twitter, some people say X. Yeah, it's X Twitter. I love it. That was Sanjeev, if you're watching remotely with the pun. Here's Facebook. Again, we have threaded discussions. You've got an algorithmic feed. You've got a search bar to find things that aren't in your feed, and you have threaded replies to stuff on the feed. Let's suppose that somebody posts something that you don't agree with. You think it's well-intentioned but off base. You can't believe it's true. You go down the rabbit hole and you spend an hour trying to figure out actually what the numbers are. And okay, there might be a little truth to it, but there's some more context. You spend an hour writing a post. Who's going to see your post? Only people who are reading this particular thread. So that same meme, in the sense of an idea that's in circulation, that same meme is going to show up in a lot of other posts, and the people reading those posts are not going to see all of your great work. So why should you even bother? Because your work's going to be trapped in the thread. Here's another example, slightly different. This is the New York Times website. This got 1,900 comments, this particular article. And here's comments down the side. The algorithmic feed, in this case, just ranked by the number of things which, the number of votes that the post got, which means mostly the people who answered first. If you scroll through this, you'll find some people saying kind of the same thing over and over, and then a few dissenting views buried in there somewhere. So again, it's hard to find the interesting stuff. There's a reply structure again. You can see some threaded replies. But this is moderated, but it is hard enough to moderate. And so moderation only suppresses the worst posts. It doesn't deal with the redundancy problem. It doesn't deal with showing you appropriate context for each post. And manual moderation is hard. So this is an opportunity for LLMs. People object to it. They really get pissed off at sites when they spend time writing a post and it gets killed. But they suspect the moderators of bias. They may suspect LLMs of bias also, but there's at least some defense on the part of the site that they can be transparent about what they're doing and say, well, these are the kinds of prompts that we're using, and you can see they're not taking political sides. Many sites have actually just turned off their comments rather than attempting moderation. So I already mentioned that the sites are kind of disorganized. And so we think of what we're trying to do on this team as curation. There's lots of stuff out there. We're trying to show you a view which is curated and showing you just the vegetables which would be good to eat in the context of the other stuff you're eating, so that you get your full complement of vitamins. Okay. So we want to promote and organize the best posts. Get some kind of balanced discussion, but at the same time, we want to let people talk to their friends, reply to everyone they want. They can eat what they want. We're just giving them other options. So one interesting thing about these sites is that they're all kind of optimized for a phone. So there's like one column of stuff, and then there's all this space to the side that's being more or less wasted. Maybe it's being used for advertising. Here we've got a sponsored post, but mostly there's this one column. One column of comments. So we're focusing in this user interface on a desktop where you can add a second column of other things that maybe you should look at. You don't have to look. So I'll come back to this one here. Let's just talk about the proposed interface. So you still have threaded discussion among friends. That's in the left column. But over on the right, you get easy access to other things that might be relevant from this site, and maybe stuff that we've imported from other sites also. So we're trying to balance the social activity of talking to other people with the intellectual activity of discussing an idea that's not attached to people. All right, so here's a little demo of the, we're building this now. This is just a mock-up in PowerPoint. So here you get your feed. Here's a post from Carson. Let's hover over it. If we click on it, we focus that post and we can now see the replies. And this post here is not very public. This is just somebody's, personal status. But this one here is making a sort of public-facing argument. And we're going to need LLMs to identify which those posts are. And you can see that there are actually a lot of people, 183 people, making roughly the same argument. So science told us, something like that. Being able to extract that argument, being able to group those posts together isn't trivial. That's part of the work of the summer. So if we click on this reply to focus it, now we see here on the right column some other stacks of posts. Each of these stacks is reasonably homogeneous. Here are a couple of high-quality stacks that are agreeing with this argument, and a high-quality stack that's making a prediction. So we have some different icons here that you could click on. So if you hover over this, you can this tab, you can see some different icons. People who are agreeing, disagreeing, saying, taking a step back, saying funny things, giving values, which are not evidence, giving quantitative evidence, giving personal evidence, making predictions about the future, making proposals to solve things. There's a few other categories that we've thought of. So we're just making this stuff available. If you're like, this can't possibly be true, let's look at some people who disagree. You can find the people who disagree, but maybe you'll also click on the people who are providing evidence for or against. So if we explore this stack over here of posts, so if we click on it in the right way or double click, it breaks up into substacks. So this is hierarchical clustering. So they're all in the same stack because they say sort of the same thing, but it's not the identical thing. And so we break up, and we're always trying to put a high quality post on top. So in the left column, the post on top of a stack is the post that's actually part of that thread. But anytime you see a stack that's not there because it was threaded, for example, it's being shown in the right column, or it's a substack of an existing stack, we're trying to promote the things that are actually thoughtful, responsive, give a reason for saying what they're saying instead of just saying it, explain why it's relevant. We could also, in principle, do fact checking. I think that's beyond the scope of what we'll be able to do this summer. So there's one more piece here. So we've been talking about curating the reading experience. There's also curating the posting experience. Okay, so we click here. We're going to reply to Kira. So we're Charlie in this case. Fortunately, we don't have to do the research ourselves because somebody over here already said something interesting, so we can just quote tweet it. That got surfaced for us, and let's add our own comment. Great. Unfortunately, the comment here is kind of jerky. And the AI might actually be able to tell us, first of all, it's not quite responding to Kira. And second, some people might call you out for not being not being sensitive to the people who are being hurt, or not thinking far enough into the future. Some people might agree with you. But to get some sense from real replies or that are pulled from elsewhere on the site, or AI simulated replies, what kind of feedback you might get. So we're going to put in a little delay where, as people are editing, they get comments and they're not able to, at least if it looks public facing, they're not going to be able to post until they've had a few seconds to look at the replies. So a little bit of friction. And this is better, we think, it's just intuition, than waiting until they posted and then having a bot come in and saying, stop bullying, which is embarrassing people in public. OK. Any questions at this point? Yeah. Sorry.
When you say you try to design these stacks to have kind of a high quality post on top, right?
Yeah.
What have you thought about in terms of how you're going to actually measure the quality and
hold that question. I've got a slide about it, and this is open territory for the summer. So feel free to come to our meetings and give your own suggestions. And it's like we all have to figure this stuff out.
Jason, I had another question as well, but I think Karthik has one first, so let me get to him first.
So this is all really interesting stuff. When you talk about like the categories for prediction and hypothesis and so on,
Yep.
will there be a step in there where it will search or check for logical fallacies like strawman arguments or
Yes, we
where
could do that.
it makes sense, but like it's actually not logically consistent?
We could do that. There's another question which is also important, which is it consistent with external facts? The LLM, if it's reasonably up to date on the issues that people are talking about, may actually be able to fact check it and say, this is a common misconception or something. This depends on the training data, so it's a little worrisome. And our nightmare scenario is we spend a tremendous amount of time building this site, and then word gets around, oh, this site is biased toward this side or that side. They're using a woke LLM, whatever. So you can't trust it. And then the idea of bringing people together and showing them what each other are thinking falls apart because it might not totally fall apart because we might be able to pull in posts from other sites, but still we're only reaching part of the intended audience.
I mean, the reason I was asking is from an architecture point, those are two slightly different things. Like fact checking is more about information aggregation and comparison.
Internal consistency is
whereas the other one is chain of thought reasoning, which, okay, cool, thank you.
Yep. The latest LLMs are, they're a little expensive. So the question is, can we distill them, for example, into models that do this faster? Because taking every public-facing post and asking, is there a logical fallacy, using chain of thought is going to, we have to do this small scale to begin with.
I had a comment, but I think you might address it later. So if you will just...
You want to hang on to it?
Yeah.
That's it.
It was about evaluating what you're doing.
That is also open.
Yeah.
That's it.
Carry on.
Okay, so this is the basic idea. Cogent ideas get wider exposure, and we help posters write more constructively in the first place. Such a design could be deployed on a new site, and we're building one, but it could also be used, say, in the comment area at the bottom of the Baltimore Banner newspaper, and it could also pull in comments from other sites that other newspapers that decided to network with the Baltimore Banner to share comments. So there are a number of functions of political discourse that an interface like this might be able to support. So one is to help everybody understand the different sides of the issues and the different facts that bear on them. There are other reasons that people talk to one another. So the famous example with Twitter was the Arab Spring, where democracy activists in Egypt were using social media to organize. In general, it's not just being confronted with your opponents, it's also finding your allies. So one very nice thing with our interface is when you type, other posts that are relevant as you start typing a new post are popping up in the margins. So you're replying to your friends or putting in a new post about Barbenheimer or something, and you're getting these interesting things. You're like, oh, these people are more interesting than my friends. I'm going to join their conversation instead. So can you find other people who are thinking like what you're thinking? So we hope to support that with this interface. Then there's a question about whether the annotation that we're doing could help some kind of data science independent of the user interface. So if you are, say, the Federal Communications Commission, and you're passing new regulations on net neutrality, and you're required to call for public comment, you now get over 1 million public comments, if I remember right. And sorting through them and figuring out what people are saying requires some kind of curation. So a lot of people are saying essentially the same thing. They're saying, I am for or against this policy, with more or less the talking points that that were suggested to them through an email campaign. But if there are genuinely new arguments in there, you'd like to be able to find those out. And this same technology should be able to provide curated views for decision makers who are consuming the discussion. And then the other people who are consuming discussions are journalists, policymakers, and social scientists. So there's a bunch of worries that we have about this, and we're happy to take advice about which of these we need to do something about and what to do about them. Some people might just, when they see opposing points of view, they might react against them by becoming even more firmly entrenched in their current view. And the question is, how can we show people things? How can we design a user interface so that doesn't happen, either by being careful about what we show people or by showing it in a very gentle way? It could be that people just don't like the interface for some reason. It's too busy. They don't want to have to use a desktop. They don't like the delay before they're posting. Third issue is that we're trying to give play to different views. Some of those views will be coming from bad actors. LLMs are going to make mistakes. So maybe, in fact, the stacks are not coherent, and the ones that are being shown in the right column are not relevant to the post that's focused. People might, as I was saying to Karthik before, might just get off the site because they think it's biased. Creating the site is hard, and there's compute cost issues. Okay, so this was, sorry, is it Christina asked this before? Yeah. Yeah, so how do we decide which post should bubble to the top of their stack? So there's a number of different criteria that we've been thinking about here. So we have quality. So here are a number of dimensions of quality. I can come back to this later and just leave it up for people to look at. Also enjoyability, like we want to actually make it more fun to be reading stuff. Is it relevant to the post that it's supposed to be relevant to? When we're showing a bunch of stacks that might be relevant, do they complement one another? Are they, even if you've got two stacks, both of which disagree with this post, are they disagreeing for different reasons? So it makes sense to show them as different things. How do we balance quality with diversity? And also, how do we give the reader a sense of which views are very commonly held and which ones are fringe? We don't want to mislead people into thinking that fringe views are have the same weight as widely held views. So that's the representativeness idea. And then finally, we may want to, in the interest of being social, we may want to show you people that you know or feel you know. So people who are your friends or followers or followees, or who you've replied to before, or who you've seen before. And we should be thinking long-term here about incentives for users to behave well, whatever well means, in a pro-social way. So there are different metrics that we might use. So there's going to be a lot of prompt engineering here, and this I'll pass through this in the interest of time. It's related to the previous slide. So we're trying to make a first draft this summer of something that kind of works and has all the infrastructure there, and then in the fall we'll be able to do user studies. And we may also need to refine whether the prompts are doing the things that we want them to do, in the sense that they align with human values. So some NLP problems that we want to solve. We need to evaluate the quality of the post, and there are many questions that we might want to ask. Some are contingent on other questions, like, does this post make a claim? If the answer is no, we don't have follow-up questions. But if the answer is yes, is that claim relevant to the subject under discussion? We need to, as well as evaluating quality, we need to provide feedback on the lapses in quality. We need to somehow cluster the posts hierarchically to get our stacks that are splittable into substacks. But it is tricky to do that, because we don't just want to say two pieces of text that are similar should be in the same stack. The similarity isn't about the style of text. It's not about the words that are used in the text. It has something to do with whether they're making the same argument. And so we might have to extract that argument in neutral language. Exactly what we want to extract, what the basis is for clustering stuff, is something we're going to be working out over a series of meetings. And we need to be able to find out which things are relevant. And also, when we display a relevant post, if we ripped it out of the middle of a thread, it might not be intelligible outside of that context. You use a pronoun like she. Who is she? You want to be able to replace that by Kamala Harris. Or otherwise, replace a little bit of context, or provide a little bit of context so people can see when they're glancing in the margin what it means. If they click on it to explore further, it'll fly into the left column and be shown as part of its thread with its original wording. So in the future, you could imagine that we might use interaction. I think we started 5 minutes late, so I've got another 3. Yep. Okay. We want to learn what to show, maybe from feedback from users, which is what all the main social media sites do. And we might in future want to summarize activity. Okay, so our starting point is something called Mastodon, which is like Twitter, but it's open source and it's also federated, so anybody can start up their own server that will talk to the other servers. So we're writing a new client, which means the front end design. What you're seeing on this slide is the standard client, but people have written others. So this is the user interface that people see. We're writing a new one. And then we have to modify the server a little bit. We want that server to, Mastodon doesn't have that many posts, unfortunately. So we're going to be pulling in posts from other sources so that we can get really focused discussions on particular articles, like from Reddit or the New York Times, where you've got a lot of people talking about the same subject, and we can curate that. And so we need the server to pull in posts from different sites, and all the posts on the server have to be classified, categorized, and evaluated. So we're building a new client. As I said, this is what it looks like today. This is all fake data. We should be able to, hopefully this week, hook the pieces together and be able to look at the real data. And some of our tasks this summer. So we need to pick our data and settle on our values. So that's the political science and sociology. We've got a lot of prompt engineering questions. What's similar? What's high quality, or particularly high quality in a particular context? We need to be able to rewrite posts and provide feedback. We've got HCI people, human-computer interaction people on our team who need to evaluate whether the user interface is working well. And there's a lot of software engineering to make all this stuff work and allow us to play with it while it's actually running. The machine learning problems. If we collect some human judgments on things like similarity, quality, and relevance, we want to take, the LLM might be wrong, but we can post-process the LLM judgments to align them better with humans. We can try to speed up the LLM judgments by predicting them from embeddings or from a subset of the LLM judgments, so we don't have to make as many LLM calls. And then there's some questions about how to build the stacks so that we get good, tight, and diverse clusters. And then final question, which was Sanjeev's question, how do we know we're doing well? What data are we collecting to test that? What are our metrics? And what kinds of user studies do we want to plan ahead for? Okay, well, here are our wonderful, brilliant undergrads. Here are our wonderful, brilliant grad students. Here are some wonderful folks who are not here in residence because they have to be other places this summer, like New York and China, but they've been working remotely, and some of them will be in some of our team meetings. And here are our not necessarily brilliant faculty, as you can see from our comedy poses. And you can see that the people other than me have worked on AI for political discourse before. So that, I think, is all I have to say. Oh, with one final comment here. I can get this to go here. Yeah, so this is a little different from most of the JSALT teams in that we are not training on large text collections necessarily. We're using the LLMs, which are trained on large text collections, to do most of the work. Our training will mostly be on smaller data sets to try to align LLM judgments with human judgments. So it's more like information retrieval or topic modeling or something, that the text collections are the things that we're analyzing as we actually run. And it's not about human-machine conversation, which is what some of the other LLM projects this summer are about. A lot of people are doing that, and it's incredible. I'm doing it half my time anyway. It's incredibly important work. It's not human-machine. It's human conversation. And that drives a lot of real human activity. It could be useful for discussions that aren't political also.
You could have stopped
So this
at
is
three
LLMs in the
humans.
service of human-computer interaction. And so it's exciting to have this interdisciplinary team, which has a couple of NLP people, an HCI person, and a political scientist.
You could have stopped at three humans because they say two's company and three's a crowd.
Well, we're social media is crowded and we got to deal with it.
All right. Thanks, Jason.
Yep.
We have time for one or two questions. If there are any, oh, Karthik, and then.
So given how exciting this is, I have to be the person to ask the bad counterfactual, which is,
Oh, please, yeah.
if you were a bad actor using this system,
Mhm.
how would you game it?
Well, the more transparent we are, unfortunately, about our prompts, the easier it is for you to use our prompts yourself to try to optimize a post that meets your needs, while at the same time passing our filters for and getting featured as having high quality. So there's a danger that people might be able to mine this even if we don't release the prompts because we're giving people feedback.
Yeah.
And so if you use the interface in an automated way, you might be able to optimize the post. There is an XKCD, which might answer your question, which is about how about the arms race between spammers and AI. But what happens when the spammers manage to outwit your AI by posting thoughtful, constructive, valuable stuff? And the answer is mission effing accomplished. Yeah, but in fact, that's the spammers will be able to outwit the LLMs without being constructive, probably, and so it will be an arms race.
Okay. Antonio said he had the same question, so I think you answered both of them.
Yep.
Right. Thank you, Jason. We'll have to stop because we are a little bit
behind. Half an hour for talking, 15 minutes for question?
No, 25 and 5.
My mistake.
All right. So let's move on. Richard has a question which you'll have to answer in the brown bag lunch.
I'm so sorry.
That's right. Okay. Thank you, Jason. And
Okay.
let's bring Samir on. Yep. I mean, go on. Put this one on. Yeah. Okay, you should be all set.
And just do this. How do I get this?
Go ahead. If it's trouble, you could stop it.
I think maybe stop sharing and then no.
Well, let's see what it does because
Yeah.
there's a simple way to switch it.
Oh, okay.
So let's see what happens next. There you go. Looks like it's all right.
I know. I just wanted the speaker notes.
Oh, you want
Yeah.
the speaker? Oh, hold on. That may not be possible because it's not like we have two screens.
I see. I see.
How do you want to do it?
I think that's okay.
Do you want to just get out of full slide share, full screen mode and just read them?
No, I think it's fine.
Okay.
It's fine. Yeah, yeah. So yeah, I think Sanjeev mentioned our team name, multitask, multimodal, audiovisual. But I think we have evolved into a universal audio generation team. There's still multitask, multi-modal component, but I think this title reflects better our, what we are trying to achieve here. So this presentation is in collaboration with my team here. So the goal is really to build this audio generative model that can be prompted for different audio generation tasks. So, comparing with like text LLMs can be prompted for different text generation tasks. We want to build something similar for audio generation. The context here can be multimodal, like text, audio, image. Depending on the context, there are some prominent audio generation tasks that our model should be able to perform, such as text-to-speech synthesis, text description to music generation, spoken language translation, so speech-to-speech translation, and audio enhancement and source separation. So this is an overview of our method. We have this two-stage modeling process. The first stage is compression. So we'll build this compression algorithm that embeds your high-dimensional audio signal into some low-dimensional latent representation. Then the stage 2 consists of modeling a distribution over these latent representations conditioned on the context. So to map the context to audio, we basically generate first the latent structure from this conditional distribution, and then there's a deep neural network that maps this latent representation into the audio recording. So let's look at some overview of the compression algorithm. So it's simply a hierarchical variation vector quantized autoencoder. Here, the encoder embeds the audio into latent representations at different levels of abstraction. The decoder tries to reconstruct, conditioned on this latent structure, the audio back. There's also this vector quantization module that discretizes the representations from the encoder into these hierarchical latent codes, A3, A2, and A1. I think people who are familiar with language model technology might have guessed. Now, we'll build the generative model on these latent codes. But yeah, that's in a few slides. So these are our hierarchical latent codes. So this is a pictorial representation of our compression algorithm. Some intuition about the high-level, top-level tokens. For this, I actually need the speaker notes, but anyway. So the top-level tokens are like capturing semantic features from audio. The mid-level tokens are capturing more structural details of the audio, such as like phonetic segmentation, phonetic categories, sound events, onsets and offsets of sound events in the audio, and other structural details. The low-level tokens are capturing more fine-grained details about the signal waveform to ensure that we can have like high-fidelity audio generation. Actually, this type of hierarchical, unit learning has a lot of history in literature, like starting from early 2000s from cognitive scientists like Sharon Goldwater at Edinburgh and James Glass and his students. And also, I think Sanjeev and Florian have worked a lot on zero speech challenge, right? So over the years, but recent state-of-the-art methods have basically neural quantization methods that we will also try to implement here. So now, once we have the compression algorithm, the next task is to build the generative model or model this distribution over the latent representations. So building this conditional distribution conditioned on multimodal context is quite difficult because you would require some paired multimodal context and audio data to train this system. So instead of conditioning on the multimodal context, we condition on text. There's a lot of text and audio paired data available. So this should be easier to build. So this is the factorization of our distribution over the latent representation.
Interrupt you for a second. If you go back a slide, when you say you need paired data and you said you have a lot of audio and text,
Yeah.
You're not thinking merely speech and transcripts, right? You probably also want
exactly.
audio with some kind of description.
Exactly. And we have those data sets like music paired with text descriptions and general sounds paired with text descriptions as well.
Got it. Thank you.
Yeah, recently there are some big data sets that were created over the past couple of years. So as I said, our latent representation has these three token representations that we learn. We factorize this distribution in these three terms. The first term is the conditional distribution over the top-level tokens conditioned on text. The second term is the distribution over mid-level tokens conditioned on the top-level tokens. And the third distribution is distribution over the low-level tokens conditioned on mid-level tokens. So the dependence on text is only on the first term. So this is the pictorial representation of our generative process. So the generative process is as follows. Given some text, you first generate the top-level codes from this conditional distribution, and then the mid and the low-level codes conditioned on the previous tokens. And then once you have this latent structure sampled from your distribution, your conditional distribution over the latents, you can generate your audio by just passing that latent representation through a pre-trained neural network. This decoder, by the way, is just the decoder of the hierarchical VQVAE that we built. So how we model these distributions is using autoregressive language models. I mean, these are just discrete token sequences. So we can use all the language modeling technology to model these tokens. The top level distribution, we can initialize this language model using a pre-trained text-based LLM, because we hope that the top level codes actually learn some text-like semantic representations. The other LMs, we would try to keep them lightweight. And by the way, the top level LM would require some paired audio and text data to train, but other ones are unsupervised. Okay, so now the goal is really to actually prompt this generative model using multimodal context, not text, right? So currently it's not possible because context is different from text. It can be audio or images. So we built a translation model that translates this multimodal context to some representation T prime, which is approximately close to a text-like representation. So this is our translation model. This is inspired by work on query transformer. So this model consists of a transformer here, which has self-attention and cross-attention modules. This model is conditioned on modality-specific features that are extracted using pre-trained modality-specific encoders. So these features are frozen, and only the query transformer here is trained. The query transformer is trained using supervision from a pre-trained text encoder. So an intuitive way of understanding the query transformer is like it's translating the representation, these modality-specific representations, to a text-like representation. Now, when you are prompting your text conditional distribution here, P, Z given T, you will send instead the output of the query transformer to your generative model. I think depending on the gap between T prime and T, we would probably have to fine tune a little bit the query transformer, but that should be quite efficient. And we have some evidence in literature where people connect the text language models with the vision encoders to make it multimodal language model. So I think we'll follow a similar strategy.
So, Samir, one more similar question then. So if you can go back one slide. So earlier we had said that you'll need some, maybe not this one, maybe the one before this or after this. There was, no, keep going forward.
Sorry.
Yeah, this one.
Yeah.
No, the one before this. Yeah. No, wait. It's
I think I have. Yeah.
Go forward. Yeah, stop here. Good. So earlier you had said that we'd need some paired audio with some text description of the audio. Now it looks like you need a number of things in different modalities paired with their text. Okay. And you are envisioning this as paired because that's how the contrastive loss can be computed.
Exactly.
Right? Okay.
So yeah, I mean, we have, for example, audio text pair data as we discussed, and image text data, a lot of it also exists.
Right.
So I think we should be able to train this system.
Got it. Okay. Right. Thanks.
And also like using text as conditioning for building the generative model is also so we can use pre-trained text LLM for the top level code. Yeah.
Right. Okay. Thanks. And actually the good thing about this architecture is that the encoders on the very left, you're kind of agnostic to them as long as they put all three modalities or whatever into a relatively nearby space.
Exactly.
You can then bridge the gap with your Q format.
Yeah, exactly. So like text is kind of a binding agent between the generative model and these multimodal contexts, right? So we are translating all the context into text-like representations, and we also have a generative model that is built conditioned on text.
Okay.
Yeah. So hopefully you can prompt the generative model using this multimodal context.
All right. Thanks.
Yeah. Yeah, that's a good way of looking at it. Yes. And that's exactly what the Q-former was used in previous paper as well. The main competitor for our work is the paper from Microsoft this year in ICLR that has the same motivation, like building a single model that can do multiple audio generation tasks. The difference is that in their case, they had this encoder-decoder framework, and the multimodal context is directly mapped to the low-level tokens A1 in our hierarchy. I think one advantage of our method is like enhanced control over the generative process. If we can like disentangle information at different levels of abstraction, we can probably control the generation more precisely. And also, if you see in our model, the dependence of the context is at the high-level codes, which are much more compressed than these A1 codes. So this mapping should be easier as well. Yeah, but there will be more technical details in the coming weeks, and this will become more clear, I hope. So our contributions in this workshop will be this hierarchical audio codec, which we are working on currently. The starting point for this hierarchical audio codec is the Descript audio codec that only learns low-level tokens. And we want to add some elements to that model to learn hierarchical codes. Then the other contribution is the hierarchical audio generative model on these hierarchical tokens, and a multimodal context encoder for prompting this hierarchical generative model using multimodal context. Right? And then, basically by prompting this generative model, we'll be able to perform multiple audio generation tasks. We have our team breakdown in these three projects, the hierarchical audio codec, the generative modeling, and the multimodal context encoder. And yeah, we have some good balance of PhD students, and there's some undergrad student as well. Yeah, and you will see, you'll hear more from these people in the coming weeks. So progress so far, so I think one of the hard things were to prepare an evaluation code base, because you have all these tasks that have their own evaluation metrics. And there are many tasks that we want to perform. So we have actually prepared that code base. We have some top lines and state-of-the-art results, like state-of-the-art task-specific model results for individual tasks. And now we want to compare our model against these numbers that we have. So our model should be, hopefully will be close to the state-of-the-art task-specific models and not too far away from it in performance. And yeah, you'll see some results in the coming weeks as well. I think that's all I had.
Thank you. We have time for questions. Marek.
Yeah, hi. Just to make sure, what parts of the architecture are you going to train, like end-to-end? What are you going to pre-train? Maybe on the image that Sanjeev was.
Yeah, good question. So you're talking about the generative model in particular?
Yeah.
Okay. Yeah. So in generative model, as I said, like the top level generative model, we can probably initialize with a pre-trained text LLM, because there's text involved, and the A3 tokens, we are assuming that there will be more text-like. And these models will be probably pre-trained, probably trained from scratch.
So when you combine different modalities, because in my talk I also said that we need to align probably the vision with the So you are like counting on the models to be like out of shell prepared for this, or do you think you will need to?
So these encoders are like pre-trained encoders for each modality, like vision transformer, some XLSR or wave-to-wave model here, some text encoder here. This will be trained from scratch. Yeah.
And will you like fine tune or freeze the encoders?
Oh, we'll freeze these features. Like we'll just follow the recipe that Blip2 paper followed to bridge the gap between like a vision encoder and text LLM. Yeah. So they also froze the pre-trained encoders as well.
Yeah. Okay. Yeah. Thanks.
Thank you.
Other questions? Other comments? By the way, I had this strange feeling when you called them A1, A2, A3, because the auditory cortex also has these regions.
Oh, really?
But I think they mean different things over there. It's just funny because they also call A1 the first bit where you like get the audio, the auditory nerve into the cortex. And so,
yeah, I think one motivation for, I suggested Josh McDermott as plenary, because I wanted to understand more if there's some connection we can make with this codec that we are building, and what he's, because he has probably more understanding of these things.
Right.
Yeah. So, but.
Yeah. Okay. No, it's just. I don't think the connection is real. I was just for a moment I was like, oh, is he thinking of? Okay.
Yeah, but I think definitely if somebody has more intuition about these things, the codec that we are building and some grounding in other fields, I think we'd be interested in like learning more or guiding our model with those intuitions.
Right. Okay. Here you go.
Thanks. So I'm part of Samir team, so I'm a bit biased about the question, but I will ask the tough question, but how do you deal with the efficiency perspective, since like for each So for generating the codex, you will have 3 language models,
Yes.
and then for generating the audio, you need also a language model,
Yeah.
and you need also encoders that
Yeah.
all of them should be on a VRAM of a GPU. So or maybe not, but it depends.
Like these different language models can be trained independently, right?
Yep.
Yeah. So,
but at inference, like if you want to do an inference, then maybe you'll need a lot.
Yeah, could be
of
a little
VRAM.
bit tricky. Yeah. Yeah, we can discuss. I think you can come up with some solutions, I guess. But I mean, so there are ways. Actually, the real answer is that there's non-autoregressive models as well that are much faster to generate,
Yeah.
but they are not quite state of the art as the autoregressive models on discrete tokens. So that's why I did not put them here. But yeah, I mean, there's a recent work from Meta called Magnet, which is like a non-autoregressive model on these type of tokens. So we can look into that later, you know, once we have some initial results.
And do you plan like to add like maybe a new project about doing quantization and things like that, so that the inference is quite fast?
Yeah, I mean, if you have time, for sure. Yeah, I'm open for everything. Yeah.
Okay. Thanks.
Right. Any last questions? All right. So thanks again, Samir. Yep.
Oh, sorry.
You see, I didn't see you, Ryan. Sorry. So we were saying that we had a nice time in the summer school, and we were mentioning low battery. Oh my God, what's going on? I need a charger. And then we also have sign language. This is also our very first time having the sign language session, and also the neural audio language models as something happening before the actual workshop. So it was a pleasure hosting all of you here during the summer school. And what is going to happen during the next days? So it's going to be pretty packed. Okay, you're going to be busy all the time, right? But apart from working, today we are having the opening presentations, and we are almost over with that. Then we will have a steering committee, just team leaders and us discussing how is the workshop going, etc. We have a welcome picnic today, so don't forget about that. Okay, we have a lot of cookie breaks, just to mingle around and know your peers, and who knows, perhaps in the future you will collaborate with all of them. Okay, we have the undergraduate a brown bag lunch on Fridays. So don't forget about that one. There will be faculty there, and you will have to, oh, the superstars are already here. So yeah, I will introduce them later. So just wait for it. And then about the cookie break and everything. So it is important for you to have that break so that you can talk to other people and make your connections, etc. We have a plenary lecture every Wednesday from 10:45 to 12. Then we have lunch with the speaker. We have a bunch of very, very, very good speakers. And also be prepared for August 1st and August 2nd, where we're going to have the closing ceremony. So you really need to work very hard. Okay? So be prepared for that. And the location, you already know where to go, right? At least the people that were here last few weeks, you know where to go, to the Malone building. So astrophysics and large language models will be Malone 122, sharing the space with democratic discourse. So that is Jones Wu and also Jason's group. Okay, you will be sharing the room. Malone 122, that is where the summer school lab was happening last weeks. And also we have sign language model in Malone 128. So that is beside 122, and audiovisual transformer, Malone 228, that is on the second floor. Okay? Yep, makes sense? Yep, you know where to go?
I was going to say, Paula, this is an inversion of power. The students know where to go and the advisors have to ask them.
Yeah, exactly, exactly. Yeah, that's for sure. And the welcome picnic. So later today, Mason Hall East Patio. Okay, the students know where to go. So advisors, be prepared. Okay, yeah. So when they start going there without saying a word, just follow them. Okay. Okay. And cookie breaks are in Malone South Lobby. There will be nice cookie breaks in the Malone. I think it's the first floor. Okay.
Isn't that what we do? Anyway, okay.
Barton 117. Oh, Barton 117. Oh, okay. Okay, so yeah. So we will notify it later, I think. And the underground, oh my God, yeah. The undergraduate, that we can also be underground, right? Why not? The undergraduate brown bag lunch is Malone 107, okay? So we will get together there and we will discuss your research every week, okay? So be prepared for that. We are nice people, so don't be scared, okay? And the plenary lectures and the progress reports are gonna be here, Hackerman B17, okay? So every Wednesday, be prepared for that, okay? Those ones are a little bit more serious. And the ice cream social, that is going to be at Barton Lounge.
So Ruth, you're saying that that's 117? Okay, so lounge is 117.
Okay, okay. The farewell dinner, it will be in the Gilman Atrium, the building where's the clock. So that is the Gilman Atrium, okay? And the plenary lectures, there will be very, very nice speakers in the very different domains, going from computer vision, the planetary science, somebody from Merle discussing a little bit about machine learning and speech, person coming from ethics and I think ethics and policy, right? Astrophysics, Dan Jurowski from NLP, and some others. Yeah, okay. And our superstars, okay, just that are taking care of us all the time. Okay, I will like to say thank you to Ruth first. You're the best. We are nothing without you, Ruth. You're the best, okay? Julia, where's Julia? Julia, okay. Maya, okay. Dan, where is Dan? Dan over there. He's in charge of the CLSP, CLSP things. Karen, our new physician. And Myra, that is here, taking care of the finances. a picture. Okay. So that is us. So now everyone has to proceed to Malone South Lobby just to get a tour. Probably St. Jill will be our guide.
Yes.
Okay.
Right.
Thank you. Thank you very much.
All right.
for
Any
being
last questions?
questions?
Okay.
Things that you want to say?
Ruth, you want to say anything? Hi. Yeah. Yes.
And but Julia, I think we could take some people to the JSALT office to get the J card.
Okay, Julia, who all do you need?
I just on there, yeah.
Okay, workshop participants, who doesn't yet have a J card? This is your Hopkins ID card. So if you don't have a J card, go with Julia, because if you don't, you can't enter the labs. All right. Okay, everybody else, follow me to